Hello friends, welcome to my channel Let's Learn. So today we are going to discuss about this service mesh. So first, what is the service mesh? So service mesh is basically a design pattern that is being used along with the microservices. So if we are creating the microservices and suppose there are 5 or 10 microservices in our applications, and when we are hitting one microservice, and to give the final result, that microservice A needs to communicate with the microservice B needs to communicate with the microservice C, and so on. And then after communication between these microservices, we are going to get the result. So how these inter microservices communications are happening? So this things is being solved by the service mesh. So earlier, how this intercommunication was happening? So earlier, service A was when we were hitting the service microservice A, and then to communicate with the microservice B, microservice A was hitting the API gateway by passing the URLs of microservice B, and thus it was going through the network, and then it was hitting the microservice B, and same thing was happening for the other microservices. But now things has been changed, and if we are using the service mesh, then we can avoid this network things. Network, we can avoid to send our control to the network, so to decrease some latency and to increase our performance. There is one separate discussion may come that we can use this message based system for microservice intercommunication. So that is also one thing we can use, but here I'm not going about those messaging queue based communication. Here I'm going to discuss about the service mesh. Okay, so how service mesh is working: Sidecar proxy and control panel. So here Sidecar proxy is basically injected into each pod, and whenever one microservice is trying to hit the another microservice, then it basically hit this Sidecar proxy, and then Sidecar proxy basically get the information from its corresponding container, from its corresponding microservice container, and it's give the result. Thus our control doesn't go to the network, and it just revolves within the microservices cluster, within the Kubernetes clusters, and from there only it create the result and give us the all the output. So these things we can understand from this diagram. So first we will have to create our microservices. So suppose here we have created all our required microservices like order microservice, user microservice, payment microservice. So these microservices are basically used in any e-commerce domain, and then we will have to use the Docker to create the images of each of these microservices. Then we will have to publish these images to the DockerHub, and then we will have to run the Docker desktop. I'm speaking all these things in terms of Windows environment. I'm going to run all these things in the Windows environment, so for that we need the Docker desktop. So we will have to run the Docker desktop, and then run the Minikube, and after that we will have to create the containers from these images. From these images we will have to create the containers, and these containers will start running under the Kubernetes cluster, that is the Minikube. Okay, and in each of the ports of these containers we will have to inject the Sidecar proxy, and then we can run the postman, and then we will hit the user microservice, and then user microservice is internally interacting with the order and payment microservices, and then it is giving us the results. And this inter microservices communications is being implemented here by using Istio. So Istio is basically creating here the Sidecar proxy and one control panel, that is the envoy control panel. So here in this envoy control panel we can add multiple things. It is basically a layer where we write all the configuration related things. So here we can implement several other things, like we can implement if one microservice is trying to interact with another microservice, then we can implement here authentication, we can implement here authorizations, and we can implement here rate limiting, we can implement here a few request response filtering filtering logic we can implement here. So all these multiple things can be done in the control panel of this istio, and in this service mesh design pattern. So istio is one library to implement the service mesh. Along similar to istio, there are other libraries also available, but in industry istio is very popular. So let's go step by step how we can implement this. So for that, uh, our prerequisite is this. First, we need to install the Docker desktop in our Windows environment. Okay, and this Docker desktop is basically providing us the different commands of Docker that we can use for creating the images. And then we will have to set up the environment path of this Docker desktop. Then we will have to install the Minikube will provide us the Kubernetes cluster on our Windows environment for creating these POCs. And then we will have to create one registration in the DockerHub. DockerHub is basically a repository for all the images that we are going to create by using the DockerHub. All the images that we are going to create by using the Docker, we will put those images into the uh, DockerHub. And when we will trigger the Minikube, then Minikube will pull all the images from the Docker Hub, and then it will create the containers from these images. So here our system should be connected with the internet, so that we can push the images to the Docker Hub, and then Minikube can pull those images. Okay, so these things are the prerequisite. Now once all these things are done, then we should once restart our system, and after that we should open the first thing that we need to do is to open the Docker desktop. So for this we will have to just write here Docker desktop, and then this is coming, and then just click over this open, and then it will take some time, and then it will open like this. So this is the Docker desktop. So once this is done, then you will have to come to your browser, and after coming to browser you will have to just type here dockerhub.com, and here I have already registered and I have already logged in. So similarly you will have to also register here, and once you will register, it will create you it will create a username for you, and whatever the images you are creating in your local system, you will have to push those images here. So I have already created these images and it has been pushed here. So similarly you will have to also do. I will show you how to create the images and how to push those images in the Docker Hub. I will show all these things. Okay, so before moving ahead, first I'm going to show you what services I'm going to create, and how these services are going to interact with each other. So I'm first going to give you some high level overview, so that it will give you a bit clarity to you. Okay, so these things I have already discussed. Now let's move on to here how what services we are going to create and how these are going to interact with each other. So here in this POC I am going to create 3 services, and this is basically I have created keeping in mind about considering the e-commerce domain. So generally all the e-commerce domain requires a user service where user can register, can create its profile, and another service is the order service, where user has selected any product and he wants to create the order, then he will hit the order service. And then once order service is triggered, then it will trigger the payment service to complete the payment process, and once payment process is done, then it will create the order, and then it will update the user service that okay, I have created the order and payment is also done. So here if you see, the intercommunication is happening first. User is triggering, the client is triggering the user service that place an order, then user service is hitting the order service and to create an order, and then order service is hitting the payment service to first complete the payment process. And once payment process is completed, then payment service is replying back to order service that okay, I have completed the payment process, and then order service is creating the order, and then it is replying back to the user that okay, orders is created successfully, and then user service is giving the response to the client that okay, your order is placed. So here I'm going to create one cluster, Kubernetes cluster. Under these Kubernetes clusters, I will create separate pod for each of these microservices, and then in each pod I will inject the istio proxy. Istio proxy is basically a sidecar proxy that will sit in each pod with our main container, with our service container. And these istio proxy or sidecar proxy will handle all the traffics. These traffics may come from the outside, or this traffic may come from the another pod. Okay, so it will have to go through this sidecar proxy, and then I will create one istio control panel or istio ingress gateway. So this gateway will expose the uh, services from these ports to the outer world, and then outer world or client from outer world will trigger any one of these services. Whatever is exposed through istio ingress gateway, it will trigger those services, and then those services will interact with each other, and then it will give the final results. So this is what we are going to implement here. Now let's do this step by step. So here our first step will be to create the microservices. So let's create the microservices. So we are going to create the three microservices, that is user, order, and payment. So I have already created these microservices just to save our time, and I'm just giving you the overview of the code so that it will be helpful for you to understand it. So let's go through it. Okay, so first I'm going through the user microservice. So this is the user microservice. So here if you see, user microservice is working on the port 3001, and here one post API is there, that is the place order, and from this place order first it is triggering the order microservices, and its API is create order. So this is the post API that it is being triggered, and once it is giving some response, after getting the response, then again it is triggering the payment microservice. So if you see here, it is triggering the post request of the payment microservice, and the API name is pay, and it is working on the port number 3003. And once it is giving the results, this is the result it is giving, then once it is getting the final result, then here it is returning the response. And the response is having all the data, like what order microservice is returning, this data it is returning, and what payment microservice is returning, this is also being returned as a response here. So user microservice client is basically triggering this place order, and then inside this microservice it is hitting the order microservice, and it is hitting the payment microservice, and the response from both the microservices are being returned to the client. Okay, so this is what the user microservice. And for this user microservice we have already created one Docker file. So if you want to create an image from node application or from any application, then you will have to create one Docker file. So this is the Docker file, and in this Docker file, first I have informed that what uh, container it's what images it's want. So node 18 alpine mode I have taken, so it is a very lighter mode of node, so that's what I am taking. And working directory is basically app, so it will whenever the images will be created and from image container will be created, then it will put all the files under the app. And then copy star colon star means it will copy everything from here to the app. And then I'm using run npm install. So once it is creating, after creating the container, it should at the time of creating the container, it should trigger npm install, so that it will create the so that it will read the package.json, and it will create the corresponding uh, node modules file. And here it is exposing the port that user microservice is working on the port 3001. And then under cmd I'm giving this command. So once all is done, then it will trigger this command, that is node index.js. so it will start this service, this user microservice. So similar Docker file we will have to create in other two microservices like payment and order. So now let's go through the payment microservice. First I'm going through its index.js file. So this is very simple. Here I am just exposing one post API, that is pay, and here it is returning some response. Okay, whatever the request body it is getting, that request body it is returning the amount it is returning from the request body. Okay, and if we go through its Docker file, so Docker file is again same, there is no change. Only change is that whatever the port this microservice is going to use, that port it is exposing here. Similarly, let's go through the order microservice. So in order microservice, this is again index.js file, and here I am exposing one API, that is create order. And under create order, whatever the request it is getting, from that request it is returning the product information. And here also we have created one Docker file, and in this Docker file everything is same except this port number. So it is working on the port 3002, and it is exposing this port number. And if you go through these folders, these microservices, then each microservice is having one file, that is the docker ignore. So basically docker ignore, what it does, so in docker ignore we basically put all those folders or files that we want not to go inside the images. Generally this node modules folder, we don't want to send it in the image, because unnecessarily it will increase the image size. And if you see, we are already giving this command, that npm install, so it will already create, it will, whenever this command will run, it will automatically create the node modules folder. So there is no need to send node modules folder separately. That's why we have created docker ignore to restrict these folders, to ignore these folder while creating the images. Okay, so once all these three microservices we have created, then we need to create its image. So here if we go through the steps, so our first step is done. So our first step is done. Now here if you see, now we need to create images from these microservices. Okay, so to create the images from these microservices, we need to use this command. This is the command to create the images from our applications. So here docker build -t for tag, and here this is the user service. User service is basically going to be our image name, and this image is going to be created from which folder. So this is going to be created from the user folder. So if you see, this is going to be created from this user folder, this user folder it is going to be created. So how can we create this? So for this what we will have to do, we will have to open one CMD, or instead of opening the CMD, we can run this in terminal also. So we can come to the terminal, we come here, and we are already in the microservices folder. So we are here in the microservices folder. So we are here in the microservices folder. So inside this folder we can directly run this command. We can directly run this command. So we will put this command here, and we can just press enter. Why I have added /user? So this I have done because right now we are inside this microservice folder, but we want to create the image of this user folder. So that's why and our docker file is present inside this folder. Okay, so we will have to go inside this folder. That's why it is /user. Okay, and then we will have to hit the enter, and then it will create the image. It will take some time to create the image, but it will create. So similar command we will have to run for order and for payment also. These two commands we will have to run for order and payment also to create the images. Okay, so once we have triggered all these three commands, and then it will take some time, few minutes to create the images. So we will have to wait till that time. And once this is done, then we can come to our docker desktop, and then once we will come to the images, then under images we will see these images that we have created. Okay, so these for now these images are very small. It is just taking 133 or 130 MB on an average. Okay, so once these images, so here till here we have created the images of each of our microservices by using docker build command. By using this docker build command, so we have created our images. So till here it is done. It is done. Now what we need to do, then we need to as I have mentioned that we need to uh, push these images to DockerHub. So as I have mentioned earlier that we will have to register in the DockerHub. I had shown you how to register. So once you have registered to your DockerHub, then here you will get one option. It will give you one button, sign in Docker desktop. It will give you one button, sign in, and when you will click on the sign in, then it will ask you about your DockerHub username and password. And when you will provide your DockerHub username and password, then it will your Docker desktop will get associated with your DockerHub repository. And if you see, my Docker desktop is associated with my DockerHub repository. So this is my DockerHub username. Okay, jksnu. Okay, now these images we have created, these images are still in our local Docker. It is not pushed to DockerHub. So how can we push to DockerHub? There are the commands to push it to the DockerHub. We can use those commands. We can find those commands in the Google, or if we want to push it through this Docker desktop, that is also possible. What we need to do, we need to come here and just click over these three dots, and then we can click on push to DockerHub. So when we will click on push to DockerHub, it will ask for some messages, and then it will push to DockerHub. Same thing we can do for these three images that we have created. So these three images we will push to our DockerHub. Once these images are pushed to our DockerHub, we should verify it by going to the DockerHub that whether it is pushed or not. How can we do this? So let's go to the DockerHub. We will come to the DockerHub, and when we will refresh here, then when we will refresh it here, we will find all the images that we have pushed here. So these are the images that we have pushed to our Docker Hub through Docker Desktop. Okay, so this step is also done. Okay, now steps we can put before these steps we can put here. Okay, once these are done, start Minikube. Then we will have to start the Minikube. Till now we have created the images. Now we need to run these images in our Kubernetes cluster. And how Kubernetes cluster is created in our localhost in our Windows environment. So for that we need Minikube. So for this we will have to install the Minikube. So I have told you, and to install the Minikube we can come here, and if we search in Google that install Minikube, then we will come here on this page. And here if you see installation, we will have to select all these options like Windows, and if our system is x64, we will have to select that exe, and then we can run these command in our PowerShell. It will give the exe file, and then we will have to give the path of this exe file to our environment folder, to our environment file. So that way we can install the Minikube. And once Minikube installation is completed, then we need to start the Minikube. So for that we should open one control panel, we will have to open cmd, and here in the cmd we will have to type Minikube status. So first we should see Minikube status. So if Minikube is installed properly, then it will give you some results. If it is not installed, then it will give you some error. Or if it is installed but its path is not properly set, then it will give you the error, and you will have to fix those things. So if you see my Minikube is not running right now. Host is stopped, kubelet is stopped, API server is stopped, everything is stopped. So first we will have to start the Minikube. So to start the Minikube, the command is Minikube start, and once we will type it and start, then it will try to start our Minikube, and it will take some time. So we will have to be very patient. We will have to keep some patience here. We will have to wait for some time. Yeah, friends. So I think here our Minikube has been started. So generally it takes, if you are starting it for the first time, it will take more than 5 minutes. It will take in between 5 to 10 minutes. So depending on your system configuration, internet speed. So we will have to wait for that time, and once it is completed, then we can again try to find what is the current Minikube status by typing the command like Minikube status, and let's see what is the status. So this command usually take 1 minute or less than 1 minute, so let's wait for that. So if we see here, type is equal to control panel, host is equal to running, kubelet running, API server running, and these all running. So our Minikube is running. Okay, so once Minikube is started, let's go to our steps, then start Minikube. So this is done. Okay, this is done. After this, what we need to do, we need to install this istio library. So this istio library we need to install so that we can enable the sidecar proxies and microservices intercommunication, okay, without touching the network. So how external network, I mean to say. So how can we do this? So for that we need to run this command. So let's copy this command and let's run it. So we can come here and we can run this command. Okay, so here if we can see, the istioctl has been installed, and this is the logo, and these are the messages that it is showing what are all the things it has installed. It has installed istio core, istio egress gateway, ingress gateway. So all these things are installed. Ingress gateway we will basically use to expose any one of our microservices to the external client, and basically here we create the cluster IPs and those cluster port, and those we can expose. So generally we shouldn't expose the node port. And after this, so our this step is completed. Let's mark it done. And then next is inject istio container as a sidecar proxy in each port. We need to run this command so that later on whatever the pods we are going to create, those pods will be in those pod will have the istio container also. So to enable this we will have to trigger this command. So let's do this. So here this command has been run successfully. Now let's go for the steps. So let's mark this step as done also. Okay, so now next we need to create the deployment files for each of our microservices, and by using these deployment files we will create the corresponding pods for each of these microservices. So now let's see how these deployment files are going to look like. And generally these files are YAML files. So I have already created these YAML files. I am just going to give a code walkthrough of these files to save our time. So for this let's come here, let's go through the deployment.yaml file of user. So these all I have placed in. For these things I have created one folder k8s, that is the Kubernetes. You can give any name. I have given its k8s so that we can easily understand that all the Kubernetes related YAML files are present in this folder. So first is the user deployment YAML. So this is the user deployment YAML file, and if you see here if you might have been knowing all this syntax, so here first we need to give the version, API version. So this is my version 1, and kind is equal to kind means deployment. What is the purpose of this YAML file? This is the deployment and metadata. So for whenever we will trigger this, then it will create one deployment, and the name of that deployment will be user. And now here under specification, here we are saying that how many replicas of this microservice will be created. So 2 replicas will be created. App name will be user, and then here we are giving one template, and this template is basically used when your application, when your service will be down and Kubernetes will try to make it up again by creating the new instances. Then that case template will be used, or this template will be used also in case of the auto scaling, where Kubernetes will try to create the more instances depending on the metrics you have defined, maybe CPU utilization or request loads. So depending on all those metrics, it may think about the auto scaling and creating the new instances. So for in those scenarios, these templates data will be used. And here also it is app is equal to user, so this should be same here, like this app, this should be same. And under specification again, here under specification we are saying that to which containers we are thinking to use. So containers, here we are saying here that you create the container of user image. Okay, so container name will be user, and what is the image, from which image it should create the container. So the image is this one. So basically here, if we go through this, so this is jksnu. This is basically the username of my DockerHub repository. If you see here, this, so if you see here, this jksnu is the username of my DockerHub. So that I've given, and user service is the image name, and latest is basically the version of this image. So in our DockerHub we can keep multiple images of the same service, multiple version of the same service, and while creating the container of from that image, we will have to provide the exact image version, and then from that image version it will create the container. If we are not providing any image version, then by default it will take latest. Here anyway I'm providing the latest, and what port it should expose. So the port name is 3001. Okay, container port is 3001. And here I have given some metrics, and based on these metrics it should think about the auto scaling. So here just metrics I have given. For example, request CPU is equal to 200 M, and limit is equal to CPU is equal to 500 M. M means and then here we have created the service. So above one was the deployment, and for creating the pods and replicas of the pods, and the lower one, this part is basically for networking. So here the kind is equal to service, and here metadata means what is the service name. Service means what is this networking name, so it is user. And what is the selector? Selector should be same as the app name that we have given in the deployment above, so this should be same. And here we are saying that our container port is 3001. This container port, whatever the container port we have given, that should be the same here, 3001. And target port means external agent should connect with 3001 to hit this user user microservice. So we are exposing 3001. So we can give here anything like 5001. So if user is hitting with 5001, then we are associating 5001 with 3001. So internally it will trigger the 3001. So that's how we can hide our actual port here. So this is the user deployment file. Similarly, I have created a deployment file for order as well as payment also. So this is for order deployment, so all are same. Here I am exposing the port 3002, and rest all are same. App name is order. Okay, and similarly there should be one payment deployment file. So this is the payment deployment file. Okay, so here content port is 3003, and exposing the 3003 port. But whatever I am exposing it here doesn't mean that user will be able to access it, because this is just the cluster port. Port, it's not completely exposed to the external client. If it would have been the node port, then it would have been exposed to the external users, external clients. By using this ports, external client can't directly access it. It's for this port is for inter microservices communication. Okay, so now we have understood about this deployment.yaml file. So now we need to trigger this deployment.yaml file to get to create the corresponding pods. So for that, what we will have to do, we will have to trigger those commands from here. Okay, but right now we are in the separate directory, so we will have to first go inside that directory. How we will go? So this is basically the directory microservices. Under this we will have to go to the kf8, copy this file and come here. Why I'm coming here? Because I need to trigger these deployment.yaml file, these deployment.yaml file. That's why I have come to this folder. Okay, now let's do cd and then control v. So we are inside here, and then let's run these deployment commands. So these deployments commands are basically like kubectl. So kubectl is basically for the Kubernetes. Kubectl apply means trigger these commands, and these one here I am giving the corresponding YML file. Okay, so let's trigger this, copy it and come to the cmd and paste it here, press enter. Okay, let's wait for a few seconds. Okay, so if you see here, it is saying that deployment .app user is created and service is created. So both deployment and service are created. So as I had already mentioned here, that first part is related to the deployment. This is related to the deployment, and the next part is basically related to the service means the networking part. So both are being created here. If you go here, both are created. So similarly we need to run the deployment files for order and payment microservices also. So let's do that. So now I'm going to run it for the order deployment.yaml. Okay, so order deployment and service is created. Now let's go for the payment one. So this is the payment one. So now if you see our payment and payment deployment and payment service is created. So once we trigger these deployment files, it will start creating the corresponding pods from those images, and those pods will have the containers. Okay, containers means a pod for user microservice will have the container for the user microservice. Okay, and similarly the case with the order and payment. So now let's see the number of the pods that has been created. So for that, the command that we can use is kubectl get pods. So here if you see it has created these many ports, two as I had told you, showed you that in each deployment file we have mentioned replicas is equal to 2. So that means for each microservice it is going to create 2 port. So for order it is 2 port, for payment it is 2 port, for user it is 2 port, and 2 port it is created but ready is 0. So none of the pod is ready right now. It is still initializing. Okay, and restart, there is no restart, and is means it is showing how when it was created. So we will have to wait here till all these ports are coming in the ready state, and then we can move ahead. If these are not coming in the ready state, if it is giving some error, we will have to debug those errors and we'll have to resolve those. Generally here error comes if we do some mistakes or do some errors in our deployment YML file, or giving some wrong commands or wrong information in the service configs, then it will give the error. Okay, so after waiting for some time, let's again see what is the status. Kubectl get pods. So if we are running this command, let's see the status now. Okay, so the current status is that all the pods are running. Okay, and no restart, all the pods are running, so our pods are in good situations. So this step is also done. This step is also done. Now we need to create istio gateway. Istio gateway means it's a gateway through which is going to expose our microservices to the external client, so that our external client will hit that microservice, and then that microservice will intercommunicate with the other microservices, and it will give the final results. So that this Istio gateway is a kind of gateway that through which all the requests goes to our Kubernetes cluster. And to trigger this, we have already created this istio gateway YAML. So let's go through this istio gateway YAML file. So this is the istio gateway.yaml file I have created here, and here this is the version you can API version you can give. Kind is equal to gateway, so we will have to give here the gateway. So these are the predefined kind, we will have to give the similar kinds here. And this is the name of this gateway we have given, and this is the ingress gateway. Okay, so this should be the same as it is given here. Istio is equal to is ingress gateway, and because it is going to expose our uh, cluster node, cluster IP port, so that's why it is that's why we are going to use here ingress gateway. For the security purpose, it is not going to expose our internal port directly. Okay, so if you see here what port it is exposing port is equal to 80. Okay, it is not exposing any of the port of our microservices. If you remember, our microservices were having port is equal to like 3001, 3002, 3003, but here we are exposing the port is equal to 80 only. So external client or user or UI or any client will know this port. They will not know the exact port of our microservices, and it is allowing this HTTP protocols. And host is equal to star we are giving, so any host it is allowing. Here we can give our domain name also, so that it will allow only the requests that are coming from our domain name. Right now we have given here a star, so it will allow anything. So that is basically not secure. We should give here the required domain name, so that the request from only those domains should be allowed to enter in our cluster, Kubernetes cluster. Okay, so this is the configurations for the gateway, and now we are going to create one virtual service here. And this virtual service is basically we are going to create for the user microservice. Okay, and we have given here some name like user vs, and host is equal to star. Again, this is not a good practice. We should give here our corresponding domain name, okay, instead of star. And gateway, we have given here the gateway name that we had defined here above. Okay, so this is the user gateway name that we have given. It should be the same. And then we are exposing the API that should be triggered, or that should be exposed to the external user, and that is the place order. Place order is present in user microservice. If you see here in the user microservice, here, then you can see the place order is present. Okay, so we are basically exposing this API to the external client, not any other API. Okay, and this API can be triggered on this port, and the pod name is user. So we are basically giving here the pod name, port number, and API name. Okay, so these are exposed to the external client. We are not exposing any other microservices, because this user microservice is basically interacting with those microservices and then giving the results. So there is no need to exposing those microservices to the external client or to the external user. Okay, so this istio gateway we have created, and now we need to trigger this istio gateway. So let's take this command and trigger it. Yeah, so it will take some time. Let's wait for that much of time. Now here this command has been executed successfully, and it has created this user gateway, and it has created this user vs virtual service. So both the things has been created now. So let's mark this as a done. This has also been done. Okay, now if we want the horizontal pod auto scaling HPA functionality, horizontal pod auto scaling, then we can trigger these commands, and if we don't want this horizontal auto scaling, then it's not needed. So basically in real-time application this is highly needed, because suppose if suddenly a lot of request is coming, or load on your application is increasing, or on a particular microservice load is increasing, then your auto horizontal pod auto scaler should remain enabled, so that based on the metrics that you have defined in these YML file, corresponding YML file, based on those metrics it will auto scale your that microservices. Means it will create few more instances of your microservices, means it will initiate few more pods of your that corresponding micro services. So let's go through these YML file to get some more idea. So I'm going through the order hpa.yml. hpa means horizontal pod auto scaling. So here API version is v2. You can give any version here, and kind is equal to horizontal pod auto scaler. So this would be same as it is written here. I have given the name of this pod auto scaler, and this is basically associated with which service. So it is associated with which deployment it is associated. This is associated with order deployment. So kind is equal to deployment, it is associated with deployment, and which deployment, so order deployment. And minimum replicas should be 2, max replicas should be 5, and based on what it should auto scale, so it should auto scale based on the CPU, and when the CPU utilization crosses this limit, then it should start auto scaling. So minimum, there should be minimum 2 replicas always running, and if load is increasing, CPU utilization is increasing, then it can increase the number of pods of order deployment order service, and the maximum number of the pod can be up to 5, not more than that. And once load decreases, then it will destroy those extra pods or extra replicas, and then it can come down again to 2. So this is for order HPA. Similarly I have created for user HPA. So same thing is there, deployment is equal to user, same it is there, and for payment also I have created. So now let's run these three HPA services, HPA YML files. So it will take some time, so let's pause this video for a few seconds. Okay, so if you see, it has successfully triggered this YML, and it is giving the message that order HPA is created successfully. Similarly, we will create the other two we will trigger these two other HPA files. Okay. Okay, so here if you see, we have triggered all the three HPA files, and all the three corresponding horizontal pod order scalars are created for user, for payment, and for order. Okay, so let's mark this step as done. Okay, now next step is I have created the circuit breaker YML for the payment user. So this is completely optional, but in real time it should be there. And basically what it does, and that it implements the circuit breaker pattern. And what the circuit breaker pattern, suppose our user microservice is hitting the payment microservice, and for some reason the payment microservice is down, then it will not be able to give the response. And then our user microservice will have to wait for some time till it is getting timed out. Okay, till the payment microservice is getting timed out. And this way it will increase our latency. So what will happen, what this circuit breaker pattern will do, that if this kind of failure is happening for certain threshold value of the time, so certain number of threshold values, then it will mark this connection as a failed. And it will close these connections. And whenever the further request will go to the payment API, this circuit breaker itself will give the message. Okay, and once this payment API will become up, then it will start allowing the request to the payment API. So this is what the circuit breaker pattern does. So for this also I have created one YML file, and this one I have done only for the payment API. So let's see what is done here. So here if you see, kind is equal to destination rule, and this is the payment circuit breaker. And host, who is the host is basically the payment port, payment deployment. And here connection pool max connection is equal to 1. And here it is saying that the pending request is equal to 1. And consecutive errors, if consecutive error is happening 1, then it should uh, it should stop further requests coming here. And ejection time is equal to this, max ejection time is equal to this. So these all configurations are given here. So let's trigger this YML file also. It's completely optional, but yeah, in real time we should implement this. Okay, so this is also created. Now let's go to the steps and mark it as a done. And for once, let's see what are all things we have created till now. So for that we can run one command, that kubectl get all. So it will give all the ports, all the services, all the deployments that we have created till now. So for example, if you see here, it is giving you all the ports here along with its current running status. It is giving all the services that we have created. It is giving all the deployments like user deployment, payment deployment, order deployment, it is giving here. And here it is giving the HPA, the replicas that we have created here. No, this HPA is here that we have created. Okay, so all the things, all the informations it is giving here that we have created till now. Now what is the next step? So next step is saying that get the external IP that is exposed through the istio gateway. So the istio gateway that we have created, now what IP it is exposing, that IP we can use to hit our user microservice, because we have exposed just user microservice, and this user microservice is having only one API, that is place order. So only that API is exposed to the external environment, external client. So for that, first what we have to do, we have to trigger this command, that is minikube channel. So we can trigger here this one, minikube tunnel, and once we will trigger this, then it will keep running, and then we will have to keep this window open, and we can't do anything further in this window. So for any further command, we will have to open a separate cmd file. Okay, so for that, let's open let's wait for some time to get it complete, to get it run, and then we will come back. Okay, so if we see here, it is giving us the message that is starting the tunnel for the service istio ingress gateway. So we should not close this window, as I have already told. It will we will have to keep it open, and we can't write for the commands here. So for next other steps, I have opened another cmd window, and here we can write the further commands. So what is the next command? So this next command will give us basically the external IP, this external IP that is exposed by the istio gateway, that we can use in our localhost. So let's see what is that. Basically it will be 127.0.0.1. It will be because it's our localhost, but in real environment it will be something else. So let's see what it is. So yeah, if we see here, this is the cluster IP, but we do not need to think about this cluster IP. We need to think about this external IP. So this external IP is this one. So we need to hit our user API by using this IP address. So let's copy this, and then we'll have to open our postman to trigger that post request. So let's open this postman. My postman is open, and I have created one request here, post request, that is http://127.0.0.1, and here I am passing the port is equal to 80, as I had shown you in the istio gateway that we are exposing this 80 port. Where is the istio gateway? Here if you see at the point here, we are exposing the port is equal to 80. So this port I am giving here, and place order, so place order is basically this one. We are exposing this place order from user microservice, and how it is being exposed. So this is also being exposed from here, from this virtual service. If you see here, we are exposing it. Okay, so if we come here, we are keeping here place order, and when I am passing this input data, JSON data, and if we are clicking here, then it is giving us some response. Okay, this is it is giving here the order information, and it is giving here us the payment information. Okay, so these information it is giving. So this user API is basically interacting with order, and order API, order microservice, is giving this response, and then again user API is interacting with payment API, and then payment API is giving this information, and then user API is merging all these responses and giving us the final response. And here the services are communicating with each other by using this one. So what man, and then from here we are hitting this istio gateway, and then istio gateway is heading this user service, and then user service port is interacting with the order service and payment service, and then it is finally giving the response to the istio ingress gateway, and that istio ingress gateway finally forwarding this response to the postman. So this is all that I wanted to cover here, and if you have any suggestion, then please put it in the comment sections, and please do like and share this video. So that's all for today. Thank you.